Right now we're going to be looking at our Chapter 7, Section 3, Part B, Class Notes. It's a continuation of what we started before, talking about how to solve multivariate linear systems and use row operations to do so. So this first example is a review. Solve this system, this 4x4 system, using augmented matrices and getting it into reduced row echelon form. So go ahead and pause this video right now and try it on your own first. Or if you have completely forgotten, keep watching. And here we go. So first, an augmented matrix, again, is going to look like this. We're going to grab the coefficient matrix, right? So 1, 2, -3, -2, 2, -3, 2, 3, -3, -2, 4, 4, and then 2, 1, -2, -1. And then I personally like clearly separating my coefficient matrix from my solution matrix, -14, 6, 2, 2. So this is my augmented matrix. And the first thing I'm going to do to put it in reduced row echelon form, first I'm just going to aim for row echelon form. Right, so row echelon form is where you had 1s, 0s, 1s, 0, 0s, 1, 0, 0, 0s, 1s, right? And we don't worry about what's up top yet. So first thing I'm going to do is I'm going to take row 1 and I'm going to multiply that by -2 and add down. Actually, no. The first thing I'm going to do is I'm going to take row 2 and add it to row 4, because then I can zero out this spot right here. So if I go row 2 plus row 4 and put that back in row 4, again, we're going to do this. I'm going to do multiple things kind of at a time just to save room. So if I do that first, if I add these two rows, 2 plus -2 is 0, -3 plus 3 is 0, -2 plus 4 is 2, 1 plus -1 is 0. Hey, that's nice. 6 plus 2 is 8. Right? So that's what I put into my, that's what I'm going to do first. Then what else can I do? Now I'm going to say, all right, so I'm going to multiply row 1 by -2. So -2 row 1, and then I'm going to add that to row 2, and I'm going to put it back into row 2. So -2 plus this is, oh, I don't want to zero it out though. Yes, I do want to zero it out. See, this is the thought process you think though through. I've got a 1 up top here, so I absolutely want to keep that 1, 2, -3, 2, -14. Now I want to get a 0 here and a 0 here. That's kind of my first goal here. So I was able to get a 0 here by just adding rows 2 and rows 4. Now I want the 0 here, so if I multiply this by -2, -2 times 1 plus 2 is going to zero that out. -2 here is going to be -4, plus -3 is going to be -7. -2 times -3 is going to be +6. 6 minus 2 is a +4. -2 times 2 is -4. Plus 1 is -3. -2 times 14 is going to be a +28. 28 and 6 more is going to be 34. All right. And then to get 0 here, I'm going to go just 3 times row 1 plus row 3 and put that back into row 3. So 3 times 1 is 3, plus -3 is going to be 0. 3 times 2 is 6, 7, 8. 3 times -3 is -9. -9 and +4 is going to be -5. 3 times 2 is 6, minus 2 is going to be 4. 3 times -14. 3 times 14 is 12, carry the 1, 42, but that's going to be -42. -42, and 2 is going to be -40. All right, so we've zeroed out our first column. Now again, our next goal is to make one of these have a 1. And so in my opinion, the easiest way to get a 1 here is just to add these two rows together, right? Because -7 and 8 add up very nicely. So I'm going to do this, but I'm going to rewrite my matrix here. So I'm going to keep the first row the same. So 1, 2, -3, 2, -14. And then I'm going to add row 2 plus row 3, and I'm going to put that sum back into row 2. If I add these, That's going to give me a positive 1, and so that's going to get put back into row 2. That's what I want to replace row 2 with. So row 2 is going to become 0, 1. 8 plus negative 7 is 1. 5, negative 5 and 4 is negative 1. 4 and negative 3 is positive 1. Negative 40 and positive 34 is going to be a negative 6. All right. So I've made a 1 there. And then, yeah, because I tend to make algebraic mistakes very easily, I'm just going to do that single operation for this row. Oh, no, I'll do one more thing. I'm going to go ahead and, because I'm going to want a 1 here eventually, if I swap rows, I'm going to go ahead and say row 4 times 1/2 and put that back into row, I'm going to put that into row 3, and I'm going to swap row 3 with row 4. So what did I say I was just going to do? I was going to put row 3 here, 0, 8, negative 5, 4, negative 40, and then I'm going to go 0, because then this will already be a 1, 0, 4, right? If I divide both of these by 2. So I've got 1, 1, 1. So far, so good in my just row echelon form for now. And now, again, I want to get a 0 here, and then I want to get a 0 there eventually. So to get a 0 here, I'm going to take my row 2 and multiply it by negative 8. So negative 8 row 2 plus row 4, and I'm going to put that back into row 4. So again, keeping everything else the same, being very careful I don't make copying errors. 0, 1, negative 1, 1, negative 6, 0, 0, 1, 0, 4. Notice I've already solved that z is going to equal 4. Now 0, okay, so negative 8 times 1 plus 8 is 0. Negative 8 times negative 1 is positive 8. 8 minus 5 is 3. Negative 8 times 1 is negative 8. Negative 8 and positive 4 is negative 4. Negative 8 times negative 6 is going to be a positive 48. Positive 48 minus 40 is going to be a positive 8. And so, moving on, I'm now going to multiply row 3 by negative 3. So negative 3 row 3 plus row 4. And I'm going to replace that plus row 4. I'm going to put that back into row 4. So, again, copying everything else. 1, 0, 0, 0. 2, 1, 0, 0. Negative 3, 2, negative 14. Negative 1, 1, negative 6. 1, 0, 4. All right, so multiplying this row by negative 3. So negative 3 plus 3 is 0. Negative 3 and 0 is still 0, plus negative 4 is still negative 4. Negative 3 times 4 is negative 12. Negative 12 and 8 is a negative 4. Ooh, so what does that tell us z is going to equal? Right, if I multiply row 4 by negative 1/4 and replace that with row 4, right, I've got 1, 1. And so that's going to put me in row echelon form. So again, row echelon form is where you've got 1, 0, 0, 0, 1, 0, 0, 1, 0, 1, right? Where you've got 1s all down the diagonals. So again, 1, I'm going to have 1 here. Leaving everything else as is for the moment. 2, negative 3, 2, negative 14. Ooh, I got to make my spacing nicer. Negative 1, 1, negative 6, 0, 4. That is my row echelon form. So now I'm going to want to put it into the reduced row echelon form, which means I'm going to basically back substitute, but using row operations. So in this case, first I'm going to try to zero out this 1 and this 2. So I'm going to multiply row 4 by negative 1. So negative row 4 plus row 2. And I'm going to put that back into row 2 to put a 0 there. And then I'm also going to go negative 2 times row 4 and add that to row 1 and put that back into row 1. So doing both of those, let me scroll up a little bit and give myself a bit more room. So what have I got? I'm going to keep the bottom row exactly the same. So 0, 0, 0, 1, 1. This is going to stay the same, 0, 0, 1, 0, 4. Again, z is going to be 1. Or sorry, w is going to be 1, z is going to be 4. And now if I'd go negative, so first of all, negative times 0 added, this is going to stay the same, this is going to stay the same, this is going to stay the same. So 0, 1, negative 1 is going to stay the same for now. I'm just focusing on changing these. Negative 1 and 1 gives me 0. Negative 1 and negative 6 gives me negative 7. And then up here, the 1, the 2, and the negative 3 are going to stay the same. Again, I'm only focusing on zeroing out the fourth column above this one. So negative 2 added to positive 2 is 0. Negative 2 and negative 14 is negative 16. All right, so now that I've zeroed that column out, I'm going to zero this column out. So to do that, I'm going to multiply row 3 by positive 3 and add that to row 1. So 3 row 3 plus row 1, I'm going to put that back into row 1. And then I'm just going to straight up add row 3 with row 2, row 3 plus row 2, and put that back into row 2. So again, 1, 0, 0, 0, 1, 1, 0, 0, 1, 0, 4, 0, 1. Now if I do this one first, if I add these two, that's going to give me 0. 0 plus 0 is still 0. 4 and negative 7 gives me a negative 3, so that's my y value. So w is 1, z is 4, y is negative 3. And here I'm going to have 1, 2, and then when I multiply this by 3 and add up, 3 plus negative 3 is 0. 3 times 0 is 0, plus 0 is still 0. And 3 times 4 is 12. Negative 16 and positive 12 is going to be a negative 4. And I'm almost done. One last row operation to do. I'm going to take row 2 and multiply it by negative 2. So negative 2 row 2 plus row 1, and that's going to go back into row 1. And so what do I have? If I have negative 2 and I add up, that's going to be 1, 0, 0, 0. Negative 2 times 3 is positive 6. Minus 4 is going to be a positive 2. And so now in reduced row echelon, it's when you've basically got the identity matrix in your coefficient side. Notice I've got my identity matrix there. And then all your solutions are listed at the end. And so what is the solution to this system? Again, x is going to be 2, y is going to be negative 3, z is going to be 4, and w is going to equal 1. Or you could write it as the nice ordered quartet there. So that's example 1 worked out in all of its beautiful glory. All right, so then looking at the next example, right? So we can also solve a system of n by n equations and n variables using inverse matrices, as long as the determinant's not 0. But using the augmented matrix method is better when you have systems that aren't squares, right? So here I've got u, v, x, y, and z, so 5 unknowns, but only 4 equations. So when that happens, I'm guaranteed to have what's called a free variable, right? If there are more variables than equations, the general solution will often be in terms of at least one free variable, maybe even more than one. Point is, there's going to be an infinite number of solutions here. So go ahead and set this system up, and in the next video, you'll see me working through it. And in fact, I'll work through it, and then I'll just quickly talk through it in the next video, so you don't see all my slow calculations. So work on example 2, solve this system using the augmented matrix method. And when you start the next video, we'll talk through the solution.